we have Lloyd Harischandra from AAO-MQ University. Lloyd is going to speak to us about the real-time data transferring and processing from remote telescopes using Apache NiFi and MongoDB.
Hello everyone, I'm Lloyd. I'm from the Australian Astronomical Optics at Macquarie University here in Sydney, Australia. So today I'm gonna talk about how we automated the data transferring and processing from remote telescopes, couple of telescopes we have here in Australia using Apache NiFi and MongoDB. Before I go into the technical details, I'd like to tell you a little bit about the old system we had and the problems we faced. In the old system, instrument software writes the data files locally into its local storage during the observational run, and at the end of the run, a night assistant would check the files to see if there are any problems, and if there are no problems, the database record will be created for each and every observation. And the data files then originally copied into DVDs to be transported to Sydney for archiving, and later we automated that transportation part where night assistant copies the files into a staging area where they are synced to Sydney every morning at 11:15. So the original the files, original DVDs that we sent to Sydney are still in these cupboards. You can see them even now. So the problems in the old system, there were a lot of missing data, and as you can understand, the software had bugs. And in fact, there was a bug which took a few years to be detected, and during all those years, some important data were missing. And then we have the difficulty in search for calibration files associated with the science frames, because not all the FITS keywords are ingested into the database, and some FITS keywords were actually missing, and wide field images were not available to be queried, and files are not available straight away because there is a lack of about 24 hours for them to be available. And this entire process was labor intensive and took a lot of resources to be managed. So to address these problems, we decided to automate this system using Apache NiFi and MongoDB. So Apache NiFi is a very powerful data processing and distribution system, and MongoDB, as most of you know, is a NoSQL database which stores data in documents in collections. So this is the design of the AAT archive. As you can see in the orange box, we have Minifi. Minifi is a minified version of Apache NiFi, which can be installed and deployed into resource limited computers or systems. For example, Raspberry Pi. So here, the Minifi instance monitors a couple of directories for the observational files and copies them over the internet to the main NiFi server, which is inside this green box. This connection is secure, and it uses a special protocol called side-to-side protocol. And the NiFi server is behind a firewall, and two proxies route the data. And when the data files get to NiFi server, it reads these files and extract the header and convert the header into OBSCO, which is a VO format, VO a standard OBSCO compliant JSON file, and then that file is inserted into MongoDB, and then the file is copied over to a server directory to be archived. So this is the NiFi GUI. As you can see, everything happens through a graphical user interface. And the key features. So I mentioned it's all the data flows are created using a GUI, and data management, security, and all of them is configured through this user interface. And NiFi has this guaranteed delivery. For example, if the connection drops or an edge node crashes, when all the systems come back online, the data flow can resume. No files will be lost. It is guaranteed, and the data provenance is given. Each data point, each point the data moves through can be traced and tracked, and you can in real time see what is going on with the data files, what is going on with the data. And it supports push and pull models. For example, Minifi at the telescope pushes data files, and if we want to pull data from a MySQL or any data source, we can pull it and then push them again to a pipeline if you want. And there is automatic flow control. For example, if incoming data rate is high and the writing rate, for example, is too slow, NiFi automatically reduce the incoming flow rate to balance things, balance the flow. And we have queuing, prioritize queuing, and history with rollback restore capability. So you can restore your NiFi instance to a previous state if you want. And we have flow templates which facilitates the reusability. For example, we can create a flow template for a certain data flow and save it and copy it over to a different NiFi instance and get that data flow running in that new instance straight away. And it is highly secure system. In fact, NiFi was originally developed by the NSA in the US and donated to Apache Foundation in 2014. So we can have multi-tenant security in an organization. If we want to, if a different team wants to manage their own data flows, we can create a different tenant for them. Sorry about that. And then it's extensible and scalable. So NiFi has over 200 different processors. I'll come to that later. The processors, these processors actually address almost all data flows that are available. But if you really want to create a new process, you can still do that, code it and deploy it. And also it's scalable. You can add any number of edge nodes or any number of server nodes and data sources, sinks, and all that. And it supports clustering as well. So the main concepts are flow files, processes, and etc. A flow file is a representation of a single piece of data that's in the system. It is made up of two parts: attributes, or the header, if you like, and the data that it carries. The attributes are key value pairs, and there are 3 standard attributes, which universal UID, which distinguishes this particular flow file from other flow files in the system, and file name, which is a human readable name. It is useful for storing data, and then a path, which is a hierarchically structured value, which can be used to store these particular flow files in their own places instead of all the flow files coming from all flows in a single folder. And then we have processors. Processors are the components that consume the data that comes in, process, manipulate, add attributes, etc., and then route the files to different processors or terminate those flow files. And
you have 2 minutes, Lloyd.
These are done by relationships and connections. For example, a relationship, if the processor processes the flow file properly, correctly, it moves that flow file to the success relationship. And if that relationship is connected with another processor, the flow file is moved forward to the next processor via this connection. And we have controller services, reporting tasks, and templates. I mentioned them before, the process groups and remote process groups, which allows you to group together certain data flows. So when things get complex, you can have different groups and remote groups. They are connected via input and output ports. And we have funnels to combine different connections into a single, multiple connections into a single connection. So this is where we create data flows. As you can see, top here, we have the components bar from which we drag components, processors, etc. into the canvas. And bottom left, we have the operate panel where we can start a processor or stop it or add policies, etc. And we have a global menu to configure security policies, etc. and search bar to search templates, etc. And this is the AAT data flow at the server. So as I mentioned earlier, the Minifi sends data files, and they are written into a local storage using put file, and then put file moves that data file to the execute stream command, which runs a Python script which reads this file and extract the header keywords and convert them into a JSON document and sends to put Mongo to insert into a MongoDB collection. And at the same time, put file forwards that flow file to the attributes to JSON, which extracts attributes such as a file name and file size, and all the attributes of all these flow files are merged together to create a report. And that report is sent every day, every 24 hours to the AAT for their reference via email. And this is the MongoDB document for a file, for a data file. So Huntsman, we implemented a data flow for Huntsman Telescope as well. It is a bit different because Huntsman sends in many different types of files, but we only read FITS files to extract its headers and insert, create MongoDB documents. So finally, so as you just saw, when it comes to archival data transfer and processing, it boils down to whether we want to do all these system administration tasks ourselves and create scripts and maintain them ourselves, or just do less of that and more of this. That is what we are good at, looking at creating data flows and managing where data should go and etc. So we outsource the system administration and those boring parts to a different team. With NiFi, we have our own team that manages the system administration part, and we can focus on data, data moving and data, the things with the data. So yeah, so that's about it. Thank you very much for watching.
Thanks very much, Lloyd.
Thank you.
We have a question on the Q&A channel from S. Shen. The question is this already in production? What's the
Yes.
data volume real-time streaming you're talking about here? Okay, many questions. Will there be any basic data cleaning? Will any basic data cleaning be involved before storing in MongoDB? And have you thought about using Kafka instead of NiFi?
Well, actually, Kafka, NiFi can consume Kafka data and send data back to Kafka queues. So this is mainly if we want to connect different data sources and move data between different data sources and sinks and etc. We can use NiFi to do that. Yeah, NiFi can use Kafka as well as a data producer and also a send data back to Kafka. With the cleaning, we didn't have a requirement to clean the data, but we actually do check when we read the header files. We check whether they are correct, but not really cleaning at the moment. If we want to do that, we can actually create a Python or a program to do that, and then run that program through a processor, just like we did. We read the FITS files. FITS files are read using a Python script. So yeah, we can do that if we want. Is that the question?
Thanks, Lloyd. One final question from anyone? If not, thanks very much, Lloyd, again.